When complete, this information is added to the parts routing table. This is the Preacta sequencer. The Gantt chart is shown, which displays all the machines in the y-axis, mapped against dates and time in the x-axis. The colour bars that are displayed horizontally against each machine are the various operations assigned to it in the current plan. The length of the bar is the process or runtime. Here we've highlighted the bars that represent different operations of one single part. The flow of operations from one machine to another can be clearly seen, and the times at which each is planned to start and end is represented by the start and end of each bar. The allocation of these operations takes into account the availability of machines as well as other constraints defined, such as labour, materials and tooling. The bars are automatically highlighted in red if they are planned on dates that fall on or after the required by date. Although the operations are automatically scheduled onto the machines using Preacta's sequencing engine, the planner can manually alter it by dragging and dropping the operations to a different time on the same machine or to an alternative machine. Only machines that are valid within the resource group of that operation will be allowed for a drop. In many cases, commercial toolrooms do not have an ERP or other application for sales order entry. In this example, sales orders are entered within Preacta. Here we use the sales order entry tool. Details such as customer, priority, assembly quantity and assembly date are entered. Once the assembly is selected, all the parts belonging to that assembly are displayed in the grid below. The due dates and the quantities of the parts are calculated based on the sales order details. The user can further specify whether the raw material is available or not. If not, then the raw material availability date is entered. The user can also exclude any parts from this list if they are not needed. Preacta will create production orders for each of the parts included in the sales order. The sales order information can be modified if required. For example, if the material supplier changes the dates of the material supply, this can be changed here by the user. Preacta has a bar color tool that is used to interactively change the color of the top and bottom of the bars based on the drop-down list of attributes. The planner can use this to locate specific parts, assemblies, customer orders and a whole range of other attributes. Preactor has a whole lot of standard reports built using Microsoft reporting services from the SQL tables. These provide the users with text and graphical analysis of the schedule details. Let us focus on some important reports for this model. This report shows all orders that have sink erosion operations and require electrodes to be manufactured. It mentions the number of electrodes that are required and those that are ready. The sales order report shows the different sales orders and its current status with the number of parts completed. When you click on any sales order, it drills down to show the details of different parts that belong to the sales orders and the completion status of each part. When you click on any production order, it displays the details of the operations of that order and its status. Using this drill down, the user can track every part in the operation starting from the sales order. This report lists the orders that have to be done on a particular machine as per the plan generated by Preactor. This will be supplied to the shop supervisors for implementation on a daily or shift basis. This is similar to the earlier work-to-list report, but allows the user to view the details only until a certain date. This example has shown how Preactor is configured for a commercial toolroom. There are many other examples of how Preactor can be customized in almost every type of application.